Okay, for this project I'm going to do some RF work. I've been watching a lot of Mr. Carlson's lab where he does up AM, FM and FM receivers. I think I'd like to try doing that, but it looks like a bit of test equipment I'm going to need is an AM modulator and FM modulator. So that's what I'm going to do in these videos. So the rest of this video is going to look at putting together a fairly simple AM modulator that's going to be driven by a signal generator, and they'll be used to set accurate frequencies, set things like AM dials on receivers to exact frequencies used in that. And then the second video I'm going to do a FM modulator. I found a good circuit. It uses surface mount devices, and I haven't done much surface mount device soldering, so the second video is probably going to be half and half of working out how to do surface mount devices and then looking at the FM modulator, see how well it works. Okay, for the AM modulator, I'm really just going to use a single IC that's MC1496, works pretty well. And I'm going to use it in this circuit that I got off the internet. I actually saw it on YouTube, the NA5Ys channel. You see more details there, and he goes through the circuit in depth. The main thing to note about the circuit is he's adjusted it so it just needs a single power rail, doesn't need two. Uses a voltage divider to allow the various biasing to the signal inputs that it needs. Note that the signal inputs are balanced inputs, and among other things this allows you to use the carrier adjust to adjust the sideband behavior. I don't think I'll need that for most things, but it's good to know it's there. And finally, this is just a low power transmitter, so it won't interfere with normal broadcast AM, so you can just use it for hobby work. So to test this out, I put the whole circuit together on a breadboard. You see it here. I drove it with 9 volts, because I want to use a 9-volt battery. I used my signal generator to set the various signal input frequencies, and then I checked that I was getting an AM circuit out on my oscilloscope. And then I actually tried it with a receiver to make sure the receiver was picking up the modulator signal that I was sending, so it all looks good. Okay, a bit more progress. So I moved the breadboarded circuit onto a PCB, and here you see it's connected up, and I'm also showing the oscilloscope and the signal generator at the same time. So first thing I wanted to show is the effect of changing the sideband control. So first we'll tune it in. Here we can see the normal frequency, no sideband in here, and I change the sideband control, and you see on the oscilloscope that as I change it you'll see the sidebands start to appear. So the lower sideband and the upper sideband instead of the main modulator frequency. So that worked okay. So also see the effects of changing the signal generator. So I'm going to change the modulator frequency, so you can see again on the oscilloscope, and you can hear it where the tone's changing, kind of what you'd expect. And then I'll also change the amplitude on the modulator, and you can see the effect on the carrier where you can see deeper modulation and less modulation. So that all works, so I think we're ready to go. Okay, I'm going to use Fusion 360 to design a plastic box for this. I'll 3D print it. I'm using a box that originally came from Andreas Spiers, and I think he got it from Adafruit. It's just a Fusion 360 file out there. The nice thing about it is under modify, change parameters, you can set the box sizes, the width, the height, and the depth, and it'll automatically resize the box to whatever you set it to. So I set it to fit the PCB that I'm going to use. You can see it here. It's just a nice box with a lid that clips in. So I'm going to 3D print that. Okay, so the print started. Looks like it may take a while, so I'll let that go, and then we'll catch up when I start putting the components in the box and see how the whole thing looks. Here's the completed box. So the top just clips off. Inside you see the PCB I put together earlier, and I've got a power switch with a light to tell me when it's on. Whole thing's powered by just a little square 9-volt battery. I've got an RF out, a couple of modulator inputs, and I'll show you how it connects to the signal generator. Yeah, here's using the actual case. I set up the input connectors to actually align with my signal generator plugs. I think they're 25mm apart, so it wasn't too hard to do. Yeah, I need smaller fingers though. So I've got my oscilloscope, signal generator here going into the AM modulator, and I've just got a BNC cable going between the output of the AM modulator into my oscilloscope. And turn it on, and we can see the AM signal out on the oscilloscope, so things are looking good. I'll just play with the modulator frequency. I don't know whether you can see it out there on the oscilloscope, but the wavelength's getting longer as I change the frequencies. So it all looks good. So I think I'm done. So getting the AM modulator going wasn't too bad. I had a few missteps you can see in the videos where I connected up some of the circuits not right, but it was fairly easy to debug anyway. So that's the AM modulator done. You see it running in the background, so that's going to be useful for working on radios. Next thing up is to work on an FM modulator. Like I said, that uses surface mount devices, or SMDs, which I haven't done hardly any work on. So next video I'll show you challenges and how I get on with using SMDs. And then we'll have a look at the actual FM modulator, and hopefully that works as well as this one.